got only a couple of slides. So welcome to the Brisbane user group. Quickly acknowledging the traditional owners of the land where we stand today. We want to pay respect to our elders, past, present, and emerging, and also extend our respect to Aboriginal and Torres Strait Islander people that are here today or on the call around us. Today we got a couple of big stars, local stars. Darragh's got an X as well, so I don't know if it's he won the certification of I can share my screen. I passed.
I think I'm in.
What's that X for? I wonder. I'm not sure. Is that
Oh no, it's Twitter.
Twitter? So Darragh from Power Queensland is going to have a. It's a very geeky talk, is it? Seamless database, automated with R, GitHub, and Tableau public. That's just pretty cool. And Kris from JL. Am I allowed to use the acronym? Or I need to do the full?
No, JL.
Jean-Lang Lassalle.
Yeah.
Sounds French.
Just the last part.
Yeah. I've got a few slides after, if we got time, to maybe talk about the Tableau conference. And since someone in the room was at the conference, maybe some put you on the spot, but if you guys want to have a bit of a discussion about the conference, if you saw the keynote, if you didn't, Sam can give us a brief summary. Things that got you excited about the new Tableau features or the lack of to you, but so I'm going to stop sharing. It's you.
Yeah,
You're
I
in?
think can you give me admin rights in the
Again?
because let's see how we go here.
Hang
I'm
on.
in via Chrome, which was a great suggestion.
So did you join again?
Yeah, I have.
Hang on, where are you?
Whoa. Yeah, here we go.
Participant.
I am sharing now.
Yeah, you got the full access.
Let's do it.
Double the presentation.
So people online, Victor, can you
Alright, do
see
you want me to stand up here?
Darragh's talk? Can you see?
Yes.
How do we make that bigger?
I think it's just because it's online, but you guys can read off that screen. It's pretty-
But yeah, like you said, there's. Yeah.
Can you touch? It's not touch screen. Whoa!
There you go.
Thanks, Darragh. So you got 5 minutes left.
5 minutes. Oh,
Because you're
that's
late.
all we need. So let's throw it
Should
to
you
the
then
man.
look at the camera?
I'd like to first thank ChatGPT for the title of my talk. Because I'm not sure if you call this one to talk about seamless data visualization. It's more like, well, you can title it at the end, so I'll leave it up to you. So what I'm going to be talking about today is automating Tableau product dashboards using a combination of various free to use / open source products. So if you ever want to your own kind of ETL pipeline into Tableau public dashboards, this is one way of doing it. So I was kind of thinking like, who would this be useful for? And it'd be kind of like if you're working in like, I guess, the non-profit sector where you can't afford expensive Alteryx servers or other ETL tools, or I don't know how much DPT costs nowadays. I don't even be classified in here, but this is kind of like an El Cheapo way of like standing up your own data pipeline. So I'm going to start with a bit of a story about my little brown house. This is where I live in the Gap. I bought this 2 years ago. I'm going somewhere here. I'm not going to talk about me buying real estate. But so
selling your house.
I bought this house. And at the time, not me, but my wife was pregnant with this guy. And 6 months ago, this is Frankie, baby Frankie. And it doesn't look like that now anymore. But at the time, we were like, holy crap, we really need to get out of the rental market. And hence, we bought perhaps the worst time to buy a house in the Gap, which is exactly at this point. You can see this is basically anywhere in Brisbane / Australia. So we bought pretty much where it nearly peaked during the COVID boom. I'm not sure if anyone has tried to buy a house recently.
I did that.
Don't do it. It's very depressing. Anyway, so I bought it at the worst time. And where I'm going with this is, at the time, I felt like, I spent too much money on a little brown house in the Gap. And so I was trying to find ways to justify to myself that having a huge mortgage was worth it and getting out of the rental market. And as a result, I'm telling you, I'm going here, someone with this. I did look at rental prices. So, you know, trying to figure out if renting or renting off the bank is better. So this is actually median rents in the suburb where I live over up until today. So up until like this month or last month. You can see, I think everyone, if you rent at the moment, is probably under a huge amount of pressure. It really sucks. I'm there with you. I've rented for a long time. But anyway, where I'm going with this is I became very interested in rental prices and house prices as you do whenever you become a first-time buyer to make sure that you justify your decision. I started thinking, could I measure and visualize Brisbane rents automatically without having to do anything? And I was like, so I can keep up to date with what's going on in the rental market, but also I don't have access to CoreLogic's great database system that's closed off. That would be the dream. But I was thinking, could I identify a source of consistent rental data that was updated pretty regularly? Could I visualize that data in the Tableau public dashboard and keep that data pipeline constantly open, so I would never have to manually refresh the data? If you've ever used Tableau Public or anything like that, yes, sure, you can bring the data in, but then I have to constantly keep it up to date. I wanted a way like I just sit back and relax and admire a dashboard that gets updated daily. But also do that for basically no cost. And the answer is, heck yes, I can do that. And it took me a while and a lot of study, but this is what I'm here to share with you. And in a very kind of like hodgepodge way. So I'm going to have more details on this later. But so yes, here it is. I'm going to jump to the end first and kind of show you this dashboard that I whipped up at 12 o'clock last night. But I'm not going to actually talk about this dashboard in particular. I'm going to talk about how I got to this dashboard and how it's kept automatically updated using that combination of several tools. So hopefully you're kind of familiar with many of these tools. So obviously you have to start with data, a data source. In this case, I'm going to be talking about using RTA data, so particular bond information. Prepping it. I know people may have used Tableau Prep or Alteryx or Python or whatever. I'm a big fan. I feel kind of somewhat old school using R. Does anyone use R here? No?
Yeah.
Yes, sweet.
No?
Okay, that's it, I'm gone. So I'm a big R fan, if anyone knows me. But I do love doing a lot of data prep in R. And then looking to store that data on the Google Drive. And the reason I chose Google is because, I'm not sure if it's a little known fact, but Google Tableau Public allows you to refresh automatically from a Google Drive, like once a day or something. For some reason, they allow it for Google. I don't know why.
For certain objects.
Certain objects, okay. So it works in this case. So, and that's why I've chosen Google as a data store. And then using, which may be quite interesting if people use GitHub. I'm assuming most people know what GitHub is, Git, etc. Using that as essentially an orchestration layer. So essentially doing the work. Using GitHub Actions, and then obviously visualizing the data using Tableau Public. So quite a complicated setup, and so this is going to be a bit technical, maybe hopefully a bit, not hopefully a bit boring. Hopefully it's not boring. So I'll kind of lead you through this process and hopefully spark ideas. And hopefully I'm more than willing. It's quite complex, but I'm more than willing to talk about it after. So let's kick it off. So obviously, if you can remember from my last one, starting with data. If you weren't aware, the RTA, Residence Rental Tenancy Authority, does publish median rents quarterly. That's not maybe well known. Maybe it's the CoreLogic data, and rent is much more useful in many ways. But they definitely they publish this data set here, RTA median rents data. In that, there's a lot of information, particularly around suburbs. You can actually look at suburbs throughout Queensland, what the median rents were for all dwellings and various house sizes as well, apartments, units, townhouses. You can break that up by many different metrics. So that's where I went, found my data. The data comes like this. Now, does anyone do a lot of data engineering, ETL? Yes. Can anyone see why this? I picked out 3 issues immediately with trying to ingest this automatically. Anyone have a
Yeah,
shot?
first
Like
two
how,
rows.
Top
The first two rows.
The headers.
top row, that's the first one, yes. What's next?
Like the extra column on the A column is useless.
Yeah, yeah.
What's hidden? What columns are hidden?
That's earlier. So yeah, I couldn't fit it in. I have like 8 years of data.
So
Even row 1 to 4,
Yeah.
you can use that.
So yeah, there's an issue kind of around here. They have like concatenated the flat and the bedroom numbers together, the dwelling and the bedroom numbers together, and then there's like loads of blank space. So it's like pivoted. You know, it's like a crossfire. So ideally, like, you know, you really want it in a what I call a tall.
skin.
Was that sorry? You got skinny and tall, narrow and tall. I love it. So this is why it's so great because it eats this stuff for breakfast. So I've got a lot of screenshots here. So this is some code that basically sorts out that data. This is not that it's about 100 lines of code, but I'll quickly go through the kind of
Each line.
ideas.
You're going to go through each line.
Yeah, we'll go line by line. I should point out here, I've got this great package, OpenXLSX, where I can just like basically pull everything off the web and just process it. So essentially, the processing in our script, I'm not going to go through the tech by line, as much as Kris wants me to do that. But basically, I can pull the RTA data from the web using OpenXLSX, and then clean and prepare using Tidyverse, which is a great set of packages for data prep. And then push that clean data to a Google Drive location using a Google Drive and Google Sheets package. So you can see here, I won't go through it, but basically I authenticate with Google and then just write it there. And I'm going, how long do I have? That gets the meaty part of it. What's good? Okay, I've got a bit, okay.
How many hours?
Huh? Yeah.
3 minutes.
Anyway.
About 10, 15.
So anyway, basically I've got my data, I've got my script that basically prepares it and put it into that narrow and long format that Tableau and various other visualization tools really like. Basically, if I want to automate it, I want to create my own Google robot data entry intern. So what this does, so you create, if you've got a Google Gmail account, you can log into a Google account and create the appropriate container in Google Sheets. Basically, you want to rename your columns to match what you have in your prep script. So while I've used you can actually use Python or anything like that as well. So you can see here, I've created long and skinny. I've pulled it suburb, dwelling type, bedrooms, month and year. So it's labeling, Tableau, the rental value, and also this date data updated field. I'm simplifying this grossly, but you can then, for free, create a Google Cloud project via console.cloud.google.com. You get that as your Gmail account, and then what you can do is create a project. So I created a project called Brisbane Rental Data. I've noted 2 areas there, identity and access management, and the API services. I'm going to talk about them in a bit of depth. The next bit is you want to create a service account, aka the Google Robot Data Entry Intern, or GRDEI. With that Google Cloud project, you create that service account, and what I've highlighted here, it's a bit hard to see on the screen, apologies for that. I basically create an account name, so this kind of robot called BRD, Brisbane Rental Data Service Account. And what this does is it allows you to essentially pass over that processing of the data to, it allows you to, for the Google Robot Intern, to connect from GitHub Actions, which I'll go into in a second, and run that script and push that into the Google Drive. And essentially the key bits of information you need to know here are the service account name, so BRD service account, and also this really long unpronounceable email that I will go into in a bit of detail in a second. So basically you create a service account on your Google project. The next bit is then, you want to kind of give this Google bot the authority to be able to access your Google Drive. And you do that just via the Google API, Google Drive API, which you enable on the account. You may have to do this for Google Sheets. I think Google Sheets is now deprecated. So I think you just have to do it for Google Drive. Yeah. And then finally, you want to authenticate. You set up your service account, you've given it API access. and then you go back to your original sheet, and you basically share it with that service account. So you can see here, up in the share thing on my Google Drive, I basically share this with this Google bot that I've just created. That was a lot of information. I can pause there for a second if there's any questions, or I'll take them at the end, but that all kind of makes sense. Cool, oh, that's great. So, didn't have a chance to go through this today. So it's basically, so you allow Google Drive becomes your data, if you think about it, your data entry return. The next bit is to get busy in GitHub and GitHub Actions. So, has everyone used GitHub? Has anyone not used it?
Yeah.
Yeah. People familiar with it? Okay. So I'm not going to go super in depth into GitHub. So basically, what I've done here is then I pushed my R script into its own repository. So I've got this script just sitting on a repository called Brisbane Rental Data. Basically, it sits there waiting to do something. So I pushed it on that. GitHub has this really cool area called GitHub Actions. So basically, GitHub Actions is, if you've used Alteryx, think of it as like the gallery, the scheduler, basically something you tell it some criteria, it will just run based on the criteria. The way to set it up is using a YAML file. So I can't remember what YA it is. It's basically markup language. So basically, it's a set of instructions that you tell it. You go, okay, run this process based on these criteria. I'll go into it. I know you can't read that; it's ridiculously small. I'm going to go into a slight bit of detail. So what I've done here is you set up in the YAML file. So it's basically about 50 lines of markup. I set a schedule by a cron job. So does anyone not know what cron is? I can't really describe it, so I think everyone would agree with me then. Yeah, I know what it is.
I know what it is.
But essentially, yeah, so
explain
it's
it.
called a Unix command that that's the schedule. Yeah. So what I've done here is like, okay, on the schedule, on the cron, run at, it's actually 7 o'clock UTC time, so that's Greenwich Mean Time, I think. That's 5 o'clock Australia. So I'm just saying, okay, when it hits 5 o'clock in the morning, run this script. So you can set that up in GitHub Actions. And then the next part of it is, okay, I want you to authenticate with Google. One thing I didn't mention in the previous part, when you set up the service account, you download a JSON file which has all the keys in it. I didn't want to obviously put that up on the screen. Not that I'm expecting people to write down an entire Google key, but
Take photos.
yeah, take photos. And like Acmo Brisbane Rental visualization. But essentially, what the next part of the markup file is to basically authenticate, or actually, I'm not authenticating here. What this is setting the variables that get passed to the R script for it to authenticate. So I'm like, okay, these are the two locations where I need you to put stuff or authenticate with Google. And then basically it runs the R script. So what happens when you run a GitHub action, and this will probably be the same if you're running Python, it essentially just starts a new instance of R, and then you go, okay, install these packages. So I'm like, going, these are all the package names here that I had at the top of my script. Go install the Excel package, install the Google Drive packages, DPL, YR, etc. And then it goes, okay, I go import data, run that script. Can't really see it on the screen here, this kind of thing. Just run that script. And what happens is, and I might just jump out of the thing to show you how it works, because I think it works a bit better. I'm nearly finished, sorry. Let's jump out. And Safari works now, what the hell? So I'll just quickly show you how it works, because it's a bit interesting to do it like this. So if I run, hopefully I get into the right area. So this is actually my GitHub. What I can do is like, so I've got this all set up. If I go rerun all jobs, it kind of gives you an example of what's going on. So this only takes like a minute. So basically what this is doing is I've forced it to run the schedule. So it's kind of like, see, download, it sets up R, install packages, and this will update, pushes the update to Google. Hopefully it doesn't take too long It's kind of annoying. It just reinstalls R basically. But I didn't test this before. It did work. So chat amongst yourselves.
I would say it's doing that because the cluster that it's running on has been terminated. It's
Ah,
running a
that's
resource,
interesting.
so it has to install
Yeah.
the package.
So it does all this like.
It would just start up a new cluster. Whatever GitHub's providing to execute, it's probably having to reinstall that resource on the cluster.
All right, it's nearly there. It usually takes like a minute.
It's interesting actually, just while we're waiting for that.
It's getting into it now.
It's getting exciting.
Google Forms are really good feeding into Google Sheets, and that can be updated on a daily basis.
Ah, that's
that
interesting.
works really well.
Yeah.
I used to use that for Dragon Bait. We had a nerd lab, and we'd get everyone doing their 1-2 minute learn test and putting it into the Google form, and it was automatically populating a dashboard we're using to see who's winning the lab.
You can see here it's writing to the file in Google, writing to the object. That's the one I set up initially. So it's basically going, okay, I'm writing to these two locations.
Does he update the dashboard and publishes to Tableau Public?
Basically, what happens then, it writes to that Google Sheet, and then Tableau Public then, my very next slide. What it does is then Tableau picks it up the next day, like whenever it does its thing.
Scheduled once a day.
It's all done. So I schedule it. So it just runs that once a day. In the morning, I could run it more times. Like I could just set the cron job. But I'll jump back to PowerPoint.
How often is the data updating though from the RTA?
It only quarterly. I should only send it quarterly.
Yeah.
It's not so impressive.
That wasted compute power.
So
Come on.
your RTA pull their finger out and update it. So hopefully that kind of gives you an idea of what it is. Like there's probably maybe better ways to do it, but I just thought it was a fun experiment. So, but if you weren't aware how to do this in Tableau, so when you build the new Tableau Public, which I must say is really good, and save locally now, which is actually a bit of a game changer. Suck it, Microsoft, anyway. What you do is essentially. So what you do is essentially when you're building your biz, you select from Google Drive. You'll have to authenticate, obviously, do that in browser. But when you go to save it to Tableau Public, you just make sure there's a little checkbox. It's hard to read here. So just keep my data up to date.
The other thing you want to point out to people is if you publish it from Tableau Desktop, it won't do the automatic refresh on a daily basis.
Oh, okay.
You have to publish it from Tableau Public.
Yeah, that's right.
So download the Tableau Public version.
Good point.
Publish
From the Tableau platform.
Otherwise, you'll find you set it and it just doesn't.
That's the mistake I think I first made. But,
Yeah.
So you can see here, I refreshed this morning. I can actually manually request a refresh of that data, but all it will do is go back to Google. And, so what I've done is essentially GitHub and Google take care of just pulling stuff from the web, updating the data set, and then Tableau Public connects to it. That's pretty cool. And yeah, boom.
Can you see your house on the chart on the line chart? If you go back to the previous screen, where's your house on the line chart?
Your house.
Your house.
Oh, where's my house?
Yeah.
Yes. If I go right back, no. I won't go back.
Where's your Tableau?
Well, you put in the gap too, you know.
Yeah.
Rent's a bad bit.
But we bought 20 years ago, so I'm
Yeah,
not.
I know. Anyway, yeah, you become a fully automated data platform, Tableau Public. So,
That's pretty cool.
where I think you might be going, if you have Alteryx or something like that, you might have a tool at work and you go, oh, well, that seems like a hassle. But for people who are like, working in companies that might not have a huge BI budget, or just people who just like love to see their dashboards updated without them having to do anything useful, I'm hoping to put together the actual document on how to do it, copy together from various sources. I haven't seen anyone else kind of do something like this. Maybe
Yeah, not to that degree, but the way you're using GitHub is really cool.
Yeah, it's pretty cool.
I've done it quite a few times, missing that step. So basic information coming from a Google form to a Google sheet, daily updated into Tableau Public. I live on that. I've got a half a dozen or so that they're not public.
Yeah. No. So that's it.
Any questions?
Any questions? Feel free.
Any question from online? Can I kill that thing and check? Otherwise, Thanks, Darragh.
That's good.
That's amazing. Very interesting. See, I think if you write a blog,
Yeah, one day. Because
I've forgotten everything.
6 months.
Can't you get AI to just write a blog for me?
Ah, actually, I could, and that's what I will do. So.
We're going to go straight into mine now.
Oh, shit, I need access.
Oh.
Is it because...
I mean,
So pizza gets here in 15 minutes. If anyone would like a beer, please feel free.
But let me check if I can...
There's some there.
it might just come. It might just pop up in
You
the
go.
thing.
All right.
Wow,
It's going to be.
don't make that.
This is more difficult than it needs to be, isn't it?
Something going wrong. What?
Oh, you're getting close.
Hang on.
It's going to come up in
What's happening?
Google.
Don't want that. But let me try to click on the video.
I'm going to try.
Did you send? Did
I
you share
sent it
again
to
with my
Yeah,
work one?
yeah, I did.
Oh, nice. Kind of.
And it's going to change all my formatting as well.
Because
Google-
it's
in Google,
do you want PowerPoint or is that
Can you-
good enough?
see if you can down. Can you download it? Do you have power? You got PowerPoint on this one. Get on the top.
I'm not sure because we
I
agree
like
workshop.
that
So.
Times New Roman. It's very like late 80s.
Maybe it might. I mean, I don't. To be honest, I don't really
Like,
mind.
yeah, it's very
But
retro.
See if you can open it as well.
What was that popular word processor before Word? Word
All
Perfect.
those 1, 2, 3,
Lotus.
notes.
Use that one.
Some people are showing the edge.
There we go.
So see, I need to. And if I go back to the browser
Can you do a few things?
and can you?
Yeah.
Looks like I can't share the screen because I gave you access to share screen. Oh, yeah. Share screen. Entire window. Where is
Those minutes.
I keep going. I like that. No, makes people sick. Can people online see Kris's? If you turn your mic on and then, oh, do you mind? Yeah.
Yeah, I'll check.
Can you play this one?
Yes, they can. Okay.
This one is on.
Oh.
What's that? Oh no! Oh, yeah, yeah. Oh, this for the microphone.
You have one of this.
Is that the clicker?
Oh, you can.
Oh,
Sorry,
yeah.
you can just plug this in.
Yeah, it's
Yeah.
She was. Oh,
Right. So I can control that. I'm definitely cheating and reading off some slide notes today. I gave this presentation about a year ago, and I looked at it again this afternoon. So I'm definitely going to apologise. And I'm going to have to also like click on here to change it and then press my button on here. So I get distracted. So thank you everyone. Thanks for coming along. This is my talk about need for speed in Tableau dashboards. So I'm Kris Curtis. I'm a global BI technology director at Darragh. A little bit about me. I'm from Brisbane originally. I moved to London in 2006, so a very long time ago, and was working there in data, several different big companies in Judah. So I was there for 16 years, and then my wife and I, during the whole COVID pandemic, decided, my wife's British, we decided let's come back to Brisbane, bring the family. And I'm sort of lucky enough that I've worked with some pretty big organisations, different stages of growth, and it's helped me understand like, the importance of data at these different organisations at these different levels. So as I mentioned, I'm currently at JLL. My role is really focused on how the team.
Show me to Kris.
Okay, that's working now. Okay, so my role at JLL is essentially like how the team use all the different sort of data and technology tools that leverage data. So a lot of the things around driving value through efficiency. So a lot of this software costs a lot of money, especially in large corporations. So there's several millions of dollars you like spent on type of software across all these different organizations. So it's really important that as consumers and users of the software, we are making sure that they're managing those costs and really sort of helping control, not letting the budgets get out of control. So the way that we do that we do this in 3 ways at JLL. We protect our assets and resources used for BI, such as Tableau and Alteryx, the main sort of like different things that we use across at JLL. We do a lot of innovation, so really sort of like discovering new platforms, promoting new techniques. So if someone discovers something that's going to save time or money, making sure that that is then taken internally and shared with other people. So global company, people in Australia, people in the UK, people in the US, making sure there's a communication and collaboration around the world. And finally, partnering. So we are the users, we are the BI and analytics team. A lot of the teams who manage Tableau and Alteryx and our databases there sit within IT. So making sure, part of my role is really making sure we're partnering up with these people, helping them understand what our needs are, helping them shape the roadmap of these different platforms and products to really make sure that they're getting the value out of it as well. So, talk. I feel the need for sleep. So the famous quote from Maverick in the movie Top Gun is really what I'm here for about tonight. We're going to cover 3 main points related to Tableau performance. How to measure Tableau performance, how to tune up your dashboards and improve performance, and hopefully set you up for the big win and take the checker flag by highlighting the benefits of why this is really an important thing. Equally, I think when I go into some of the more specific tips related to Tableau, but generally, I know, from a design perspective, a lot of around speed and load times and stuff really sort of plays into that. It doesn't matter what tool you use. So, sorry, I'm just trying to align with my animation. So, there's a lot of research by the Nelson Group around website response times, and they concluded that a slow page rendering is usually caused by server delays or overly fancy different page widgets. But the main thing is clear that if there's a delay, people will leave. And then from the website perspective, you go on there, it's slow loading, back, go back and find a different one. The same thing applies for any type of visualization hosted on the server that you're providing to stakeholders within the business environment. And people will sit there, see the page loading, and go, this is not worth my time, and I'm going to leave and move away from it. So there's 2 reasons why this happens. The first is when we wait, our minds are limited. We lack the control to keep focus, and we become distracted, and this can result in both loss of attention and forgetting things stored in short-term memory. The second is that we also require a desired control over the outcomes rather than wait on something. So when we think that something's not in our control, like it's something loading, then we go well, why am I don't have control in this outcome, so I'm going to disengage. So when we're made to wait, we perceive the services provider as arrogant or incompetent. So a 0.1 second response, we get the feeling of instantaneous response. The result feels caused by the user. I've clicked on something and the page loads. I've done that. I've made that happen. 1 second, okay, yep, 1 second. The flow is seamless. You can sense the delay, but you're still feeling in control. Anything around that 10 seconds, you start to drift and you start to think about other things. And it's difficult to get that brain back on track. Why did I click? Why am I looking at this dashboard? What is it chart? Why did I do that? Like I need an email. I need to reply to someone. Someone's messaged me on Teams or whatever like that. So, Before I share the tips on how to make a dashboard go faster, I just wanted to give you, how many people here use Tableau server? I'm hoping I know these guys. Yeah, okay. So one of the things I've seen a really good way of demonstrating what happens when you click on a Tableau dashboard, like what actually goes on behind the scenes. Like the end user clicks on it and then something appears, but actually understanding what happens. And there's a guy called, you can see down in the bottom here, Ben Masulo, who works for a consulting company in America called Interworks, and he produced a paper on this, a white paper, it's 16 pages long. For me, I was like, yeah, this is amazing, but you put that in front of someone else, like 80 pages of all about like, server resources and stuff, people just tune out. But it's really good in terms of summarizing something that's quite technical and complex into a few easy ways. When a user clicks on a dashboard, this is what happens. It's broken down into 4 different factors. So there's layout, query, calculation, and rendering. So when a user first clicks on it, it makes an initial request. The next step is Tableau starts to create all the different layouts of the worksheets used to create the dashboard. The number of the numbers and the design of the worksheet used on the dashboard, it has a direct impact on all the different things that are going on. So then Tableau starts building a query, and then Tableau sends the query to the actual data source and starts interrogating. So then the database processes the query, the database then transmitted the results back to Tableau. You can see how I've got these different shadings, so when the data is there and what Tableau is doing. Tableau starts then building the query, any sort of calculations and computes are taking place as well. And then it starts to render, and Tableau then transmits the results back to the browser, and then the person who's clicked on the dashboard finally sees the chart that they want to do. So it's not just like, oh look, I click on something and then there's a chart here. There's a lot of different steps that are taking place behind the scenes that contributes to this like 10-second type thing. So I just wanted to let you know what happens in that. So it's all about speed. Hot, nasty, badass speed. Ricky Bobby, Talladega Nights. There's all of these different points in here. So now that you've like had a quick introduction about like what actually happens when you load a workbook on the server, we now need to set that qualifying time, and to do that, like how we make improvements to that. So how do I see how much time it takes for a dashboard to load? So there's 3 different ways we can do this. We can see there's a feature within Tableau server called stats for load times. There's also performance recording, and the last one is workbook performance metrics. So each of these ones, I don't feel there's any of these like stand out as like the best one to use. They all have their sort of strengths and weaknesses, but overall you can use them individually or like all of them to really get a sense of like how performance is impacting that user experience. So first one, stats for load times. This is it's logical and most easiest to understand because it literally tells you like how many times each of those blue dots is one time someone has loaded the dashboard, and it will create an average value in seconds to say how long it's taken. So this is useful because it can show you how long it's taken within each workbook. So sometimes it might take a little bit longer because there's other traffic that's competing and other processes that's taking place on the server. Sometimes it might be quick because it's out of hours of the business and nobody else is online and someone's still at home doing some work, something like that. The limitations, the actual report is part of the site administrator suite of reports, so you have to have elevated privileges to be able to create this, to view this report. So just a normal standard user won't be able to see it. You do have to have a site admin permission. The next one is performance reporting. So what is this? This is Tableau's desktop inbuilt resource for capturing the amount of time each event that takes place executes. So you can see the different colors. They break down to say how long it's taken to compile the query and execute the query for your visualization. So this is useful because you can really see like is there any outliers. What is something that's doing this taking a long time? It could be a complex chart type. It could be a chart that has a huge amount of data that needs to process. So you can start to identify specific things within your analysis which might be causing these long load times. The limitation is that it's within the Tableau desktop environment, so it's not giving that same user experiences that they would see consuming that information on the Tableau server. And also interpreting the performance recorder is a challenge. I still to this day look at it and go like, what is this actually telling me? I can kind of like have a few sort of guesses and assumptions, and I know that something might be causing a long time, but actually like I really struggle with understanding this, and I don't know why Tableau hasn't improved on this type of thing, because it is really useful information. The next one is workbook performance metrics. And what was this? This is essentially it's the same thing as what I showed before, the Tableau desktop performance recorder, but you can do this in Tableau server. And so this is useful because it's more accurate. It's demonstrating what that end user will experience. The end users is that the limitation is that it needs to be enabled by a Tableau server admin. So there's a to enable this feature, you have to click on a certain thing in the back end, and you have to ask them, can you do this, enable it for me? And then you have to insert this really crazy little URL string in between that question mark character and the semicolon in order to like get it to work. So yeah, some very fiddly inserting of text in a string of URL, and then you need to reload the dashboard, and then it will start to sort of like do all those kind of like recordings of like what's happening when that page is loading for you. Again, there's still that sort of limitation of interpreting the information that's shown to you. So yeah, you can see there's some like strengths and weaknesses from all the different options. So that's where you go to enable it on Tableau server. Slow and steady wins the race. False. Fast always wins the race. Dwight K. Schrute in the office. So now what? We have, I guess like using these different resources, it sort of helps you get a bit of an understanding about what's going on. How are those end users experiencing what you produce? You want them to find the insights, you want them to understand the data that you're presenting to them, but if they're disengaged from like that first 6-7 experience, then it's going to make that job very difficult. So I strongly recommend publishing dashboards into a test or dev environment if you have that as an option for you, and simply you go through those steps of like how your end users would experience that. A lot of the times I know, like myself included, there's a rush. The stakeholder wants the report right now, and I need to see it, and you just publish it and send it off to them type thing, and then they can find, so, oh, it's just doing this thing here, and I don't know what, like, why can't I see the information? So doing that kind of like, I guess, sandbox sort of like testing, UAT, then really helps. If you then feel the performance is okay, check back after a few days or weeks, and also speak to the stakeholders. Like, are they seeing any differences? What's going on? Listen to their feedback. Has anyone mentioned the old circle, the leading circle? And if they are asking for changes, like make sure those changes are also assessed to see if it's going to make any different impact. But someone might say, hey, can we also see this, this, and this? And then if you suddenly add those things into the dashboard, you might go from something that was performing quite well to then something that's doing that. So I'm so fast that last night I turned off the light switch in my hotel room and I was in bed before the room was dark. I have a famous quote from him. Very, very clever. So what we did at JLL, one of the first things I did when I joined was pull together like a performance checklist. So we pay lots of attention to the design and how our sort of data products look for our stakeholders. But I found that there was a bit of neglect behind the underlying performance from SQL queries that are being generated, and the volume of data that was then being pushed into our external stakeholder-facing environments. So I wanted to make sure that our end users were getting a good experience with our data, and this guide was kind of put together to help our analysts sort of go through that checklist to say, hey, like, what can I do to make my, my dashboard and my charts look a bit better? So in no particular order, here's some suggestions. The first one is remove unused data sources. Sometimes people go in and they say, oh, here's a data source, here's like a sample data, and then I'll add some other data, and then what about this? And the stakeholder might be interested in this data source, and then you've got 4 or 5 different data sources coming from, you know, SQL servers, from Google BigQuery, from Databricks, wherever. Any of these unused data sources are going to create that load when these calls are made from the dashboard to the server. Even if they're not even in the chart, Tableau will still fetch that data for you. Remove unused worksheets. So same thing as like you might go, oh, here's a chart that might be interesting. The stakeholder might be interested in this, but you know, you're not going to look at it, you're not going to publish it. Any additional pieces of that dashboard will again create that load which we're looking to avoid. Hide unused fields. This is a really good one, and a really good win because people just connect to a table and then bring in like 5 or 6 different fields, but the table's got 200 columns in it. Tableau will go and fetch all those 200 columns and have them sat there in the background. So you can do something where you hide unused fields, create your data extract of that, and it's only going to fetch those fields that you're using in your visualization. And then it just basically ignores all those other columns that you don't need. If you then come back in and there's a change that needs to be made, you can bring them all back in and you can add those columns back in and go and do that. So that's a really good one. Reduce data volume. You'd be surprised to see how many people connect to a table, and that table's got like 5 million or 10 million, rows of data. And the client only wants to look at the last 3 months. And it's like, well, why do you need the last 5 years of data coming into it type thing? So definitely reducing the data volume and really sort of making sure that you're setting that either at the table level before it even gets to Tableau, or putting some data source filters on at Tableau before it even gets from that extract. You can filter it, say only want the last 12 months type thing, and then do your visualizations off the back of that. Next one is, you'd be surprised how many things I've seen. There's build complex metrics or transformations upstream. So Tableau is great at visualizing data, but it's not great at processing large volumes of data to create drastically different fields using multiple formulas and calculations. I've seen ones where people have created formulas where it's if then this, if then that 50 times. Tableau hates that. So doing that kind of stuff upstream, like Darragh sort of touched on before, those data prep tools, even if you're writing in code, like that kind of stuff in there, it's definitely going to make a huge difference to the end user's experience. Use native functions. These are things like, Tableau has some really cool features like sets and groups, hierarchies, alias, instead of creating calculated fields. They kind of do the same job. So people will create a calculated field saying, if this is that, then equals true. You can create a set that does that. If that is, if the thing meets the criteria, then it just treats it as a binary statement. So that's way more efficient. Each record doesn't have to go through every iteration of the formula to be validated. So then if it meets the criteria, it moves on. So way more efficient in that way. Reduce the number of filters. Reduce the number of filters in use. More filters equals more complex queries. More complex queries means longer time is taken to compute and execute the query. There's another use for it. So action filters. If you're not familiar with action filters are, action filters is when you can engage in the chart. So there's a long bar chart, people can click on that, and it has a cascading effect and starts to filter the data. Really efficient. So using action filters reduce the query load and aligns to Tableau's concept of guided analytics. This is the filter is only applied when the action is selected. So if you just have your filters set up and allow the user to pick them, Tableau will go through and say that every time you change that filter, it's to run all those calculations again. But an action filter will be always sat there behind the scenes unless it's actually specific. Here's another one. Limit the number of views per dashboard. So each additional visualization added to the dashboard increases the number of queries executed and the marks rendered. So if you have more than 5 visuals on a dashboard, then start to consider can these be split up. But record I have seen is 120 different worksheets and visuals in one dashboard. And surprisingly enough, yes, it did take a long time to load, and this is the reason why. And the last one, avoid high mark counts. So it might be really cool to create a scatter plot or a gist plot for 100,000 orders. But Tableau is not thanking you. Aggregations viewed as bar charts are way more efficient than multiple marks being rendered to represent each unique ID. I'm fast. To give you a reference point, I'm somewhere between a snake, a mongoose, and a panther. Right, true again. The other one is optimizer. So this is getting towards the end of my talk. So just applying a handful of those tips will increase the speed of your dashboard, and there's plenty more tips out there. That's just some sort of the ones that I really recommend to the people at JLL. There was also this feature, I don't know what version people are using, but a few versions back, Tableau released this thing called Tableau Optimizer, Performance Optimizer, which is really cool. It's an inbuilt thing. You can run it through, and Tableau will go and check to see how your things are going, and it will spit out these best practices. So this came out just after I'd done all this work about recommending best practices and all this kind of stuff. Like, cheers, Tableau, thanks. But it also makes my job a lot easier because now we can point people at this type of thing and say, hey, have you run the optimizer? And if you're getting these red flags, then like, please go and check those things before you publish. So this is a bit of a game changer, and it kind of like shortcuts a lot of those things that I talked about. So you don't have to spend your time going through all those different checklists. You can jump straight to this and see what your best practices are. And you can see this one here of like one, take action. It needs to, and then you can apply that and then publish it to Tableau server. So I'm going to stop you from publishing the Tableau server, then it'll just give you a little bit of an indication and say, there's some things in here that we can recommend you fixing. So the benefits for doing this type of thing. So yes, paying attention to Tableau is not just tick box exercise. There's some genuine benefits. So you can see increased productivity and satisfaction. You can extrapolate. Something that we did was we took dashboards which were taking a minute, 30 seconds plus time to load, and we did that exercise. We went through the best practices, we applied those things to it, and then we published it again, and we were reducing these load times by 10, 20, 30 seconds. We were then able to extrapolate how many people were consuming these dashboards in an organization. We're talking like thousands of people over like hundreds of times a day, and we were able to generate, and then you can associate like a FTE cost, how much time you were paid per hour, and how much time saving was made from that. One dashboard ended up over the course of a year saving about $20,000 US. So you can then play that back to the business by saying that 30 seconds wait time has been taken away for 1,000 users every time they view something each month. So you're giving people time back. It might be 30 seconds at a time, but it still adds up over the course of a year. So that's a really good news story that you can take to the business. There's also cost reduction in terms of the Tableau server. So I mentioned at the start, my remit is around how do we control costs within an organization. JLL has 110,000 employees. So there's a lot of overheads in terms of the different software and technology that we use. When we can reduce the need to buy additional servers and buy additional licenses, that saves us money, that keeps that money within the server area for JLL. So doing these type of things means that you're not killing your servers and you can keep that money to spend on other things. And the last is really minimizing risk. And this is from a disaster recovery perspective. So we did some testing, and if Tableau server goes down at JLL, it takes 16 hours to do a full restore of all the different content. So that means our stakeholders will be without any sort of data insights for more than a business day. So by reducing the Tableau dashboards and the file sizes and all that kind of stuff, that backup shrinks, which means your IT teams are able to bring that service back online much faster. We did an exercise at a recent sort of internal conference where we actually got people to go through that checklist, that performance checklist, and we got rid of different dashboards and fixed some up. And when they sort of republished that, it was only 1 hour for 150 people, 1 hour of time to do that exercise, and it wiped off 20 gigabytes of like file size of the whole sort of backup. It was a huge like improvement. So yes, the IT team were quite happy with that. So I want to thank you for listening to my presentation. I hope it's helped you inform a little bit about why speed is important, how to measure performance, how to tune up the dashboards and some tips. I'm going to leave you with one more quote. And this is from a guy called Guthrie Govan. People might not know. Do you know this guy? Yeah. So someone, I thought you might. You would be so. So unless you're a full-on music fan, he's probably considered one of the greatest modern guitarists. So definitely check him out on YouTube. The reason why I love this quote is because when you consider any skill, specifically like we're referencing data visualization, and Tableau, making Tableau look good or run fast takes time. It's not something you can just do once or twice. You need to really push yourself and get to the top of the game. So thank you for listening.
Any question for Kris?
Yeah, I've got one.
And I'm going to check as well online if people have questions. Maybe, but yeah, go for it. And talk loud so people online can
Hi,
listen to
Kris. Thanks. I just have one question. You mentioned that when you joined JLL, you had a checklist of like performance optimization.
Yeah.
I've been on projects where at the point of joining the project, you see how much of a mess the Tableau source or the Tableau server or the Tableau cloud is. And obviously, when you try to introduce changes, like positive changes, there's going to be